Thank you. Nice to having you here. As I'm always also introduced, I'm Jan Lindenberger from Next Generation Elements, and I'm gonna introduce you now in a little bit more a practical side of biochar production from a little bit difficult feedstock to deal with, also an efficient way of waste heat usage, and also the flue gas cleaning. So our core products are such beautiful pyrolysis machines like this, and we're also doing customized engineering of the whole pyrolysis production plant, because it's not the pyrolysis facility itself, it's always look at the whole project. And I want to give you a little bit of an overview what is currently happening on the opposite of the big lake. So this was a project we have executed at the customer in Austria. Ended early, the installation happened early this year of the second unit, and it's a demonstration of the production of a plant-based biochar and integrating this in the compost cycle and developing high valuated biochar products with it. We raised the budget for this project in sum of nearly 3 million euros, and therefore get a grant from the EU Life Fund from 60%. So we have to set up a project consortium of at least 4 project partners. So there was the compost facility itself, our company, a company who's taking care about developing a concrete additive based on biochar, and also a consultancy firm. The goal of the project was to expand the existing capacity up to 5,300 tons of wet bio-waste, what can be converted per year, and an annual production of 1,000 tons of biochar, which means 2,500 tons of CO2 sequestration. And how we are integrating this such a pyrolysis and the compost cycle. So I hope you can read the numbers, otherwise listen to me carefully. The composting facility is taking in some 90,000 tons of organic waste material from the municipality and screening it out at the first stage. The particles parts bigger than 80 millimeters. For the guys who are not so familiar with the metric system, that 3.15 inches are going directly as a feedstock into the pyrolyzer. The other waste materials are composted and screened afterwards, and from this screening stage we're taking the particles between 15 and 80 millimeters, so 0.6 to 3.15 inches, and use that also as feedstock for our pyrolyzer. So in sum, we have 5,300 tons of wet bio-waste. We have to dry it, and after drying, there are 3,200 tons per year. With the waste heat of this pyrolysis, we're going to dry industrial sewage sludges, and we're also recovering the ammonia by using an acidic scrubber for the flue gas cleaning, and so receiving ISL from ammonium sulfate from this acidic scrubber, and with that we charge the biochar when you inoculate it. So, and this gives us, through further preparation, and a bright portfolio of value-added biochar products. So, and now dive a little bit in the complex system of this whole plant. At first stage, we are going to dry the materials, the screening residues, mostly screening residues up to 15% of residual moisture. At that stage, it's fed into the pyrolysis machine, into our pyrolysis machine, and we're gonna take that waste heat in form of the off gases and going with that directly to the sewage sludge dryer. This customer is offering the sludge drying as a service, so to reduce logistical costs for municipalities, for industries, they're taking the sludge, drying it as a service. And the sludge dryer in this case is also the first stage of the flue gas cleaning, because we are going into the sludge dryer with an acidic sulfur components containing off gas and have an ammonia loaded atmosphere in the dryer. And there is a reaction similar to what in an acidic scrubber is happening already in the dryer. So already in the dryer we remove a part of the ammonia and keep it in the loop, and there is also the some back filters installed for removing the particles. After that we condense the off gases afterwards the dryer, so bring it down below 50 degrees Celsius, so to recover all the condensing energy, and this condensing energy is used to pre-dry the feedstock. After that, the acidic scrubber, where we remove the rest of the ammonia and recover some ammonium sulfate, which we use to inoculate the biochar. And at the last stage, the biofilter to remove all the odor, smell. So, and when we talk about biochar production, it's always the feedstock. The feedstock is the most struggling thing about it. And we are taking, in this project case, we are taking material like this. So it's really not clean, it's a really dirty stuff. And after the second screening, there are still a lot of stones in it. So, and to remove the stones, the customer uses like a screening bar. And so where the woody parts flow on the surface of the water, the stones going down. And to ensure that this all gonna work efficiently, we have to pre-dry the material so that this stays on top of the surface. This is how the screening bar is going to look like. If there are a lot of plastic contaminations in the screening residues, which we're often having at composting facilities, there is also the possibilities to remove the plastic contaminations at this screening bar. After that, it's chipped down to a size of 30 millimeters, so this must be a little bit more than 1 inch. And so for our customer, it's not dirty enough. He further mix it up with paper mill sludges and some husks and other agricultural leavings. So, and this is the ready prepared feedstock for our pyrolysis system. Our pyrolysis system is a very robust design, and we are focusing to keep the whole process simple. It's a screw reactor which is actually integrated in a combustion chamber, so we need no other additional oxidizer, because we are incinerating all the the pyrolysis gases within the system. And this incineration provides us the necessary heat to keep up the pyrolysis reaction itself. And the off gas with about 900 degrees can be further utilized, for example, with an heat exchanger or in direct usage with this sludge dryer. The sludge dryer is it's a rotoring shaft dryer, so the sludge is thrown in the air and we come directly in with the off gas with 300 degrees Celsius. It's controlled by the drop of the temperature to ensure that we achieve a dry material of 90% at the end of the dryer. So, and I've also told you that there are back filters already integrated in this dryer. On top of the dryer, there are some fabric filters also integrated to remove dust and achieve pollution lower than 1 milligram per cubic meter. Afterwards, the sludge is also pelletized to reduce dust exposure and make it more comfortable to handle the material. So this was the technical side of the project execution. Now to going to that, why we should add biochar to our compost. Because here we see that the C balance of the compost when we add biochar to our compost. So with adding biochar, the amount of biodegradable organic matter is significantly growing. And also the nitrogen balance shows us that with adding biochar, also, emitting nitrogen during the composting process can be decreased, and this savings us nutrition and also helps bacteria for nitrogen fixation growing. So we also have seen that with 0% of biochar, 10% and 20%, there is a significant increase of the nitrogen fixation bacteria. You can also download this diploma thesis. At the beginning, I've talked about the 4 project partners. So the company Sonnenerde is the composting facility. They run the composting facility, producing also their own soil products and soil amendments. We, as Next Generation Elements, are the equipment manufacturer. Castorcon is responsible within this project consortium to develop a biochar-based concrete additive, and Pastor Green was our consultancy who's done the administrative work to raise the funds. So, and the most important project partner is Sonnenerde itself. It is a composting facility in Austria established in 1998. And 2012, they're getting the first pyrolysis equipment, not delivered by us. Also have released the first brought on market the first biochar-based product. It was BIOCHAR-LIFE-EU, or in English, Terra Preta. Now they have approximately more than 50 different products with biochar-based in their portfolio, and all of them meeting the EBC criteria and sold as and meet for biological agriculture, and also the limits for using it as a feedstuff. So, and in 2023, we set up there the first pyrolysis equipment, and the company Jumbo set up there the first sludge dryer. And in 2025, so this year, they received the second and the third sludge dryer and have now a drying capacity in sum of 50,000 tons of wet sludge and the production capacity of 1,000 tons of biochar by the second pyrolysis plant. A little bit an overview to our company itself. We are a member of a bigger company group, Next Generation Holding, which is mainly focused on the recycling business and also especially plastic recycling. So we are a little bit the exotic one in this company group. So, and our company has in sum, the group, more than 200 employees, more than 100 million of sales revenue, and in 100 different countries around the world, we have installed more than 1,500 installations. So we also have the NGR has also a corporate office here in Atlanta, and this was the way we developed our company from the establishment in 2017 to the construction of our first electrical heated pyrolysis equipment for plastic recycling, to a direct heated system for biosolids and biomass. And now we have last year also sold this business unit of plastic pyrolysis and now focus ourselves only on biosolids and biowaste. So last but not least, there are a few more impacts of this project we should think about to scale up biochar productions, to add more economic value, bringing employment and reducing, from an environmental perspective, reducing greenhouse gas reduction, sequestration, and also more quality for our soils, waters, and achieving a better way of waste management. So, thank you for your attention, and I think it's quite fitting, that picture. This is the owner and chief executive officer of the company Sonadera. So, and we don't have a couple of minutes are still lunch, so enjoy then your lunch like he enjoys his compost. Thank you. So, are there any questions?
Oh, cool. Thanks. Do you guys have any plans to pyrolyze the sewage sludge later on?
For sure. And at this stage, I also want to speak out a big thanks to our very first customer, Mr. Shane Rannick. He's also in the audience. He's from Illinois, and he's pyrolyzing sewage sludge,
Awesome.
biosolids.
Yeah. Sorry, just other follow-up. Is the sludge that is at the site digested or undigested? I know it's not being pyrolyzed, the dried sludge that you guys are doing there.
The sludge on this side is only dried, so we haven't figured out if it's digested or not, because when we only dry it, we don't care about a lot if it's digested or not.
Thank you.
Any other questions?
So it was heartening to hear like 1,500 installations of various types, 100 different countries.
Okay, so, sorry, this was accumulated in the whole company group.
Sure, lots of knowledge.
Yeah.
You can speak to maybe the couple of projects that you shared and maybe some of the ones that you didn't. I'm trying to get an idea of roughly the, I guess, project site size based on tonnage produced or being processed. So, you talked about like, oh, the main project, consuming like 5,300 tons of wet biomass, right? I'm wondering what's the footprint in hectares or acres of a project site of that size? You showed some photos from some other sites. I'm planning for, these processing sites looking ahead, and I'm wondering what's the relationship between, I guess, material feedstock being produced and the amount of footprint you need to actually conduct the operation. Can you speak to that at all based on what you shared in Europe?
What I can say is that is one installation of us is actually needing a footprint of 30 to 40 square meters. So it's quite a small footprint. But you mean in sum what it all takes with all the material handling and that stuff? Then there is quite a huge facility. I think his whole building, like is shown on this slide. Yeah, the whole building is about 50 meters long and height of 8 meters and a wide of 10 meters. Around that, yeah. And for sure, all the material handling and the feedstock preparation happens outside of the building, so there's a lot more space around needed to get all this logistical work done, yeah. Any other question? Fine. Okay, good. Thank you.